Hey everyone.
Hi.
Hi. I'm not supposed to teach today. I actually finished all of my material through GG Taught last time. Um, I don't know what happened. I'm it's probably partly my fault because I didn't send a reminder email to the person who's going to teach. So I'm wondering what to do for today. Um, the first thing is I do want people, if you're bringing your own data, please send me an email. I'll put it in the chat. It's just Janice@duke.edu. Next week, if you're bringing your own data, please send me an email and tell me what your project, like just describe a little bit what the data set is. That's all. And I just want to know who's actually going to be doing this with me. For today, yeah, I've emailed Richard. I haven't heard back. I'm not sure if he's actually going to be available to come in or has anything prepared if he's not there yet. So should we do a Q&A? People can go through the material and ask me questions. Hello?
So I don't have any specific questions yet. I feel like they would arise more as we do like the case study analysis next week. I don't know how others feel. Maybe others have questions too.
Okay, I see. Hey, if you're in the classroom, can you press the little button on your microphone? Because it doesn't quite come, it's hard to hear on.
Yeah, you see what's happening. Oh, hi, Janice. Sorry, I said I personally don't have any questions at the moment, but maybe others have. That would be a great idea to use the time for today.
Yeah, I mean, I'm happy to do whatever you want. Some people on the survey said they liked getting more resources about R. Um, so I could talk about some of those. Um, so yeah, so like basically raise your hand or chime in if you have any questions. Don't worry about interrupting me. Um, I can show you I don't know, you're probably aware of these, but I'll show you anyway, just in case you're not. Um, Hadley Wickham's books and books that he's co-authored are this are really great to get started. You just up and okay, and I'll share my screen. If I can find Zoom again. Here we go. Uh, ah, okay, so can you guys see my screen?
Yes.
No, I cannot.
One
On
person.
Zoom, we can.
Okay, now we can.
Okay, it's just a little bit of a delay. Okay. So I thought maybe I'll point out some more resources while you're maybe thinking about questions you might have. Um, R for Data Science is a great, I think a great sort of introductory book, and it's a lot of sort of the stuff that we covered in the class. But then this will go into more. So it's like you see Tibbles, how to import data, tidy data, relational data. We didn't talk about relational data. Oh, and the string. So I think he goes into regular expressions in here. And dates and times, which we really didn't talk about at all. There's a package called Lubridate that is part of Tidyverse. That is installed as part of Tidyverse. It's not loaded when you actually call the library. Yeah, I guess I didn't really talk about that. So when you install Tidyverse, you install a whole lot of stuff like read R, a few others, like a bunch of others, like Lubridate is one of them, which is a package for manipulating dates and doing like arithmetic on dates and things like that. And that those come with tidyverse when you install it, but when you actually call the library tidyverse, it doesn't pull up all of those packages into memory. It only takes a subset of tidyverse. So anyway, so there's more to tidyverse than we've seen, and this book I think is a really, really good a good way to study it, because it's and they have exercises and all kinds of things and tons of examples. So if people are looking for things where you're looking at data manipulation and tidying and visualization, this is a really great book. If you're like me and you're a bit of a code geek, there's a book called Advanced R. And this one really gets into the guts of how R works under the hood. So, what the environments are and namespaces and things like that. So they're, environments, yeah. And so it really gets into the to the guts of things. And so there are object-oriented programming introduction. I laugh when I see this because R is not really an object-oriented language. It's something they kind of hacked together, I think, back in the 90s when it was really popular to have object-oriented languages. So there are different types of objects that you can have in S6, S4. So if you're really into like the, sort of understanding how everything works, and I think it's great. Like if you can find yourself interested in that, I think it's really great to study what is underneath. It gives you a lot of what mathematicians call intuition, which really just means experience. It gives you a lot of intuition into, like when you're trying to make something work, you can guess a lot easier how you might do it in R just by knowing kind of the structure of things and how things are done. So those are two really great books. What else do I have here? Any questions or comments? Oh, sorry, guys. I'm just like throwing this stuff at you because I don't want to, I feel bad that you were scheduled this time and now there's nothing here. But let me see. There's one other thing I wanted to recommend. Oh yeah, that's for people at Duke. So where can I find this? Research support? Yeah. What I'm trying to show you is there's actually a source in the library that helps with visualization and making slides and things like that. And I am just trying to find that service. Does anybody know what I'm talking about and remember the person's name who does this? Maybe somebody from the... See, Richard would know, but he's not here. Oh, here we go. I'm on visualize. Yes, so here we go. So at Duke, you have the Center for Data and Visualization Sciences, and you can, I believe they have open hours. Like you can go in and they have consulting, so you can consult them. They have workshops, online learning, and they even give you like data sources if you want to play with things, or maybe have a research project on some data that's public. So I highly recommend these people. They do every year in the internship part of this program, we invite a representative from this group to come give a present on data visualization and good habits for making slides for talks and things like that. So highly recommend. If you're writing a paper and you're making plots and tables and stuff, they can help you with that. They can say, well, it's better if you add this color or whatever. They're just experts on that sort of thing. Excuse me. Okay, so those are a few resources. There's this isn't fun. Oh, okay, cool. So people are happy to see these resources. That's great. Is there anything, anything you want me to point out or explain in these resources, or it's kind of thing I feel like you just go read.
Can I ask a question about next week with the bring your own data hands-on case study? So
Yes.
If we're choosing the hands-on case study that you've already defined, would it be helpful at all for us to look at the problem and look at the data ahead of time, like a week ahead, to maybe start working on that now? Or is that something that's going to take the whole next class period and starting early would just throw things off?
I'm going to punt that question to Josh because he's going to be working with the data set, for everyone, the part that's not bring your own data, that's going to be his part. So if you want to just email him, he can tell you. His email is josh@duke.edu, so it's kind of easy to find him. And he can tell you because I'm not actually sure which data set, if he's going to use the RV144 data set that we had talked about, or if he's changed his mind or wants to do something else. The RV144 data set it's interesting as a data set. It's not so interesting in my opinion, in terms of actually showcasing what R can do, and actually pulling out things that we, themes that we learned within the course. So yeah, so just reach out to him and you can ask him that question. For me, I need to know I just really need to know who's going to be doing the bring your own data, and then just a brief description of what it is, what kind of research question you're asking, what the data set looks like.
If we are bringing our own data set, do you want us to kind of follow some of the topics we've studied already? So for example, doing a little exploratory on the data, or as far as tasks when we get here, or do you want it to be more, or can we be super specific, say, to our research questions or something like that?
It's up to you. I'm probably going to be more helpful if it's just how do I arrange this data frame in the right way so that I can get the table, the visualization that I want, or how do I visualize this? But I think you can do either. And just when you email me, tell me what you plan to do. Because yes, so I can walk you through exploratory data analysis in class next week, or we can do more specific stuff. Just let me know what you're thinking about. I'm going to go over my email and see if I heard back from Richard. Yeah, nothing from Richard yet.
Can I ask, because this was going to be exploratory analysis and visualization part 3. So do you know what visualization packages he was going to teach on, or do you have any idea what his rubric was going to be?
I thought I actually, yeah, the title, it doesn't actually match what was planned, and I think that was just
Okay.
yeah, he was going to, he's a statistician, Richard. So he was going to do more of a sort of a statistics. How do you do like linear models and things like that, and that kind of thing. In the basis of hypothesis testing, but using R. So yeah, so it was gonna be statistics oriented. Now we have the second part of the workshop is also like all statistics. So this would have been introductory, but I think you'll probably cover those topics more in depth in that part of the series. So yeah, so I hope we haven't lost a whole lot today in terms of content. But yeah, we weren't. I didn't plan to go over any other packages. But is there a package or a particular visualization tool that you're interested in?
I mean, ggplot too seems like it basically has everything. I was just curious, given the titles, that there would be like a third part.
Yeah. That was so. I think those are the titles that Kelly was using, but I and me and Josh and Richard wrote a different schedule, and that's the one that I showed you on the first day. And I think we just never told Kelly to change the titles on the surveys. But if you refer to the markdown file, it's actually in your in the repository. So if you go into RStudio and you look for the in the files menu for the I think it's under data science, and then there's like a intro or something .md or something like that, a markdown file. Do you want me to go and pull that up and share my screen, or?
You're saying like it's called like intro.md in the.
Yes, that's the one. That's the one. Yes. Yeah. So apologies. This is like, so we've done this course before, of course, but this is on a new grant, and we had to change a bunch of things because it was a renewal, and we had to improve and extend and whatever on what we had done in years past. So we changed a whole lot of stuff. And yeah, I think we kind of changed our minds a couple of times. So my apologies for that. That was just sort of what was going on behind the scenes.
Oh, you're fine.
Well, and when we do get a hold of Richard, if he wants to just kind of put everything in the repository that he would have, like a markdown file or something, we could definitely, I know I'll look at it on my own before we come to the next class.
Absolutely.
Anyway. So
yeah, I can ask him to do that. I think that would be, yeah, because he's an amazing resource. I mean, yeah, I just because I'm not a statistician. I mean, I know what a t-test is, right? I mean, like, that kind of stuff. But really, when it comes down to like which statistical test should you use for this particular scenario, and what are the concerns, and and what are the pros and cons, he's really on it. So yeah, so I think it'd be great if he could make that available to you guys.
Sorry. I think I missed. I thought this. I didn't have this on my agenda as me teaching.
I'm sorry too, because I really thought I should email Richard and make sure he knows he's teaching, and I didn't do it, so I dropped the ball too.
Okay. All right.
So yeah, so basically what's been happening is I introduced a few more R resources. So I showed everyone R for Data Science and Advanced R, those two books, and then I showed them the Center for Data and Visualization at Duke, so people who are Duke can use that as a resource. And people have been asking some questions. And you just came on, but someone just asked if you could just have a markdown file of what you were going to teach today and put it on the repository.
Yeah, I can work on something like that. I have it marked down as hands-on practice today. Um,
So what
but
I've been going off of is the calendar that I thought we agreed
okay,
upon
okay,
in
all
one of
right,
our last meetings before the course started.
okay,
And that's if you look on the repo under
yeah,
um,
we can,
under data science and then intro.md, that has the schedule that I've been working off of.
okay, I see. All right. Apologies, everybody.
Okay. But I also adjusted that schedule a little bit too, because I was basing this whole course on, previous experience, which is that, people are coming in with no programming experience at all. And
Mhm.
everyone here has had some experience with R pretty much. And so I also like adjusted, and yeah, I think next year we're gonna have to poll people before and then adjust the materials accordingly.
All right. Let me yeah, I will go ahead and update that with that information and upload it to the repository.
I mean, I know this is sort of like all like kind of botched up, but one, I don't know, what you could do maybe is go through your cleaning of the RB 144 data set.
Yeah,
You feel comfortable doing
I
that
can do
now?
that.
Because
Uh
that'll
that
sort of exercise those muscles,
yeah.
and then if then Josh might actually want to do that for capstone though. So that's a little bit of a problem. But maybe not. I mean, I think you can go through part of it at least. And yeah.
Sorry. For the capstone?
So like the hands-on, the final, like the final day is going to be like, oh, bring your own data, or the like capstone, like
I see. I see. Okay.
hands-on thing. And so that's yeah, that's me and Josh, and Josh is supposed to be doing the sort of the canned one, and I'm going to do like
Okay.
whatever people bring me.
All right. Yeah.
But actually, that's great. Why don't you do that? Because I
Yeah.
mean, this is probably something that you can just do today. And you can maybe explain the data set, like the paper that
Yeah.
a
That
little
sounds
background, and then see how far you get. You probably won't get through the whole thing. And then and then we can communicate that to Josh, and he can take it from there.
yeah. I have to set this up. Let me find the I gotta set up the repository. Apologies, everybody.
So while Richard is doing that, I'm going to just explain a little bit more. This is the data set. It's a vaccine trial, RB 144. I think that's the one that's the most effective vaccine that we've had, right, Richard?
Yes, I believe so.
Yeah. But it
Uh,
wasn't effective, but it was the best one, the best one yet.
okay.
And Richard has done a cleanup of that data set, and that's the one that I think was the paper was forwarded to you guys at the beginning of the workshop.
Mhm. Yes, that was the idea. But I actually need to find it. I don't think I'm actually a member of the CFAR, um, the GitLab repository for this.
Oh, okay. So what is that? But you have the data set, and you have the
Mhm.
markdown file.
Yeah, I
You
can do
don't
it. I
have
can
the
do a
paper.
walkthrough
Is that
still. Yeah. All right. Hold on, everybody. So I guess you maybe be able to follow along um, exactly and do the same coding, but it could still be useful. All right. I got to pull this up real quick. All right. Let's see. All right. Sorry. Let's see. Private. Loading. Sorry, my R is frozen. There we go. Okay. So, yeah, this is basically, this was going to maybe be an original kind of a project that we were maybe going to kind of walk through, but just due to, it was a little bit easier to just kind of work with some of the existing data within R, which wouldn't maybe involve having to go through each of the problems without having to like load the data and whatnot, as opposed to just loading a package and putting a pre-existing data set that exists within it. So let me just pull this up real quick. R will decide to work for me.
They're antibody titers, right, Richard? This question.
Yeah, so basically it's a big variety of data. So it's from this paper from what am I sharing right now? Okay, cool. So it's from this project, basically looking at, it's called The Landscape of Binding Antibodies and T-cell responses to HIV vaccine and ties in South Africans. So if you'd like, I can put the data set is downloaded from, I'll drop this into the chat. So basically this is the data set that Georgia Tamaris and Peter Gilbert kind of senior. So Georgia Tamaris is here at Duke. She's I think the director of surgical science, right, Janice?
I actually don't know what her title is now.
Yeah, and also the director of CFAR. And yeah, she does a lot of, vaccine trials and antibody related work. And then Peter Gilbert is a statistician out at Fred Hutchinson Cancer Research Center, who does a lot of work in vaccine correlates and what have you. And so please stop me at any point. This will be pretty informal, and we can kind of figure out what's working for everybody. But basically, the project was looking at all of these different immune measures from 3 different trials, vaccine trials, and then just looking for common antibody related features that were maybe popping up that were correlated with vaccine versus not vaccine. So for this project, for this kind of walkthrough, we're just going to focus on RV144, which was a trial in Thailand, I believe. Is that? No, not Thailand. I'm thinking of RV217. No, RV144 was all in Thailand. And basically, they have data, I think, about 6 weeks post the vaccine of the second dose. And we're basically looking at, for this, kind of maybe thinking about looking at basically differences in different antibody measures between those that were vaccinated versus those that were not vaccinated. So we don't have outcome data per se, because that's in a different data repository. So this is just basically looking at this data within this group at a snapshot before infection. I'll drop in the article link as well into the chat. So, all right. Any questions so far?
I'm just wondering because we're dropping things into the chat and there are people in person. Are you guys able to get to these links as well? I think you can probably just Google the title of the paper for the.
Yeah. So this is the data set. I'll make a tiny URL real quick. Is it in the Git repository? Or is it the clean version that's in the Git repository?
I actually don't know, but what I could do, I guess, is I could work on putting that file in get, it's not very large, right? Why don't I do that while you keep teaching?
Right, right. Apologies. I think I just showed my teams. Okay. All
So
right.
let me answer the question that's in the chat. And the question is, without
Yeah.
outcomes, what are some of the research questions we are
Yeah, yeah. So I think so basically for this, so this is purely exploratory. This data set's been published on. And we are going to look at, we can look at different measures, say like, all right, what's correlated with having the vaccine, right? So we're going to have people that didn't get the vaccine, and we're going to have people that have the vaccine. We can potentially look at differences in age, differences in sex. We don't have all of the data available. And so, we basically are going to have, it's going to be very exploratory since we don't have that outcome data. Yeah. Okay. All right. So let me clear everything out. Apologies, everybody. All right. I'm going to switch to, what am I sharing? Am I just sharing the Firefox?
Yes,
Okay,
I just see the tiny URL screen right now.
great. That's great to hear. Okay. Um, all right. So next, we're going to kind of look at the data itself. I'm going to switch to visual mode. So we can see basically this is kind of my very informal playing around with RB144. And so hopefully everybody can see this. We have cleaning up RB posts. So it's very informal. And so this is basically where the data is coming from. So we have peripheral blood mononuclear cells, PBMCs, and plasma or serum samples were collected from each selected participant at 2 weeks after the month 6 vaccination, and were used to assess immune responses for the current analysis. We used data from 24 plasma recipients and 201 vaccine recipients from the RB144 trial, 18 placebo recipients, and 73 vaccine recipients for the other trials, but we're going to focus on the RB144. So to read in, this is obviously varies based on who, where you're working, but you have to specify a path to the data. And Janice, will you let me know if anybody pops anything into the chat?
Yeah, I'm trying to monitor the chat. I'm also right now also uploading this file to the repo. So, but yes, I am.
Okay,
I will.
cool. Thank you. And so we need to specify that. And that basically will then tell us, we can now go, all right, list of files, path to file. And we see like all this information here. So when I downloaded from the Figshare website, it basically gives me this zip file. And then when I unload it, not unload it, but unzip it, basically we get all this extra information like publication data for say RB144, RS row data, treatment data, and then I have other information in here that's more just meta information essentially. We can actually look and see. Let me go back. Okay. So if we look at the pub data, let's read in that. This is 144. So it's an Excel file. So we need to find out what basically the sheets are within this file. Oops.
Oh, so I just want to mention there's some new material in here that I didn't cover because I don't think I did not cover Read Excel.
Okay. So this is a way to basically read in Excel files. So it's from the Tidyverse people. You basically need a special package loaded in. So I'm going to use read_xlx. There's other ones like read.xlx. This is the read Excel package. And then I believe if we want to get the sheet, what is the sheet names function? Do you remember, Janice, off the top of your head?
Not off the top of my head. Sorry.
So you have to specify what sheet you're going to read in. Otherwise, it's just going to read in the first sheet. So there we go. That was easy enough. So basically, it's Excel. Wait, I thought it was. Is it not Excel sheets? Oh, I didn't load the libraries. All right, here we go. Okay. So if we go Excel sheets and specify this file, and we're going to specify the path to the file. So this basically is saying path equals file.path, path to file, file underscore RV144. So what this is going to look like, if we do it file path, path to file, is it's the internal path to where this data is located. So you can see it's in my box folder, in RTB35, private, R25, and then kind of goes down, case studies, RV144, land, and then I basically just pasted in the title of that. So that's just telling it, hey, this is where this file is located on the computer for you to read it in. And then if we look at the sheet names, let me type it in here. See, it'll take a little time. Say, all right, there's only one sheet in it. Great. That's what we want. So it's still good practice to specify which sheet you're reading in. But in this case, it would just read in sheet 1 by default. So we read this in, and then we can take a look at it using the view function. And okay, so it's basically, we have the name of a variable, we have the assay it's coming from, what it's looking at, factor 2, factor 3, and all these different scores, basically. So this maybe doesn't make a ton of, we're like, all right, what does this mean? So within the file, let's see, I think it's this. So if we go into the original data, I'm going to pull up the original data real quick. Bear with me. So within the data dictionary file, we can go in there and this should have it. Apologies, I know it says it's not sharing right now. I was just opening this up. So if we go into the data dictionary file, right? So everybody see this Excel file now? Great. So we see basically, okay, assay type, what it's looking at. So is it T cell subset or is it isotype? And then what is it looking at? Is it looking at CD4 function, CD8 function, IgG or IgG3? What is the antigen that we're looking at? So this is looking at which part of the envelope, I believe, that we're potentially targeting with the assay. If I understand kind of how these assays are run, and please, this is actually where y'all can correct me. They kind of put it, they put the data in, then they kind of put an antigen down to see how much the antibody, how much the PBMCs are reacting to it. What is the output? So is it a cytokine? Is it some kind of compass functionality score? Oh, that's Lynn. Okay. And then the dilution. Lynn is a professor here in the bioset department who's had a compass method. Yeah. So, and then, if it's BAMA, and then what is it, coding, what's the gene is potentially looking at within the virus. clade. So there's different clades of the virus across the world, right? And then this is basically, okay, is there a corresponding match in one of the other trials, right? So the data in this group may not, within the Thai group, there may not be a matching antigen in, say, one of the other cohorts because they're looking at different parts of the world and dealing with certain different variants of the virus. And then finally, notes and comments, which is self-explanatory. Any questions on this? This is a table in the zip file that's downloaded that they created. Or at least that's my recollection of it. Yeah. Okay. All right, let's go back to R now. Right. Okay. So now let's read in some of the demographic information. So this is going to be pub data -row selects. And again, we specify the path, we specify the sheet, and again, we could look at sheet 1. Great. They made our lives easy. And then if we look at this, you can see, okay, we have some publication information, right? We have the information on the study. We have information on the age, we have sex, we have treatment, we have race, per prot, which is, let me go back to is the per protocol cohort. So is it per the protocol? And then there's HIV infected, and then BMI. Okay. And so this isn't going to necessarily be available. And you can see here that they've given the ranges of the age to kind of protect the information in some way, right? And so if we scroll down to the RV144, loading. So the view thing is very useful, but I would say if you're doing it, make sure to close it, whenever you close your R thing. Just because it does have information there and it can be a little obnoxious. All right, so we have data demo. All right, so this is publication ID is what this stands for. And so you may see this sometimes, right, when people are publishing data sets, they don't want to give the internal study ID for the person or individual in the person or observation. So they may, come up with a publication ID, which you have to use then to map to the other files, right? So that's how we're going to do this, is use this to kind of map to the eventual BAMA and ICS data that we read in. We get some age information. We see their sex, treatment, Thai, infection, and then BMI wasn't reported for the RV144 data. But yeah, so this is what the demographic data looks like. Any questions? Okay. And so when we're coding, we kind of specify it, try to have little headers, right, describing everything that's going on, using some sort of, quote unquote, readable code, and, trying not to repeat ourselves and have the data. The file names be descriptive, which I think, Janice, you've mentioned quite a bit, right, where it's like trying not to have things named FFF or
that drives me crazy. Hey, I do have a question. Which one of these files are you? Which file is this that you're showing now? Which of the notebooks, so that I can add it to the repo?
This is which file?
So I've got your repo for the R25 RV144.
Yeah.
And I've got 0001. 02, 02.
I'm going over 01 right now.
01. Okay, I'm gonna add that to the repo.
Okay. Great. All right. And then now let's actually read in the biomarker data. All right. So again, it's pub data IR, which stands for immune responses. And so we specify the file path, the file name, and then we specify the path. And so we do that. And we're going to get a relatively ugly, to me, someone may find it beautiful, file with kind of all this information on all the different immune markers. So we see publication ID, we see their measure of CD4, GP120 specific CD154 plus cytokine responses. We see some functionality scores, and then so on and so on. We see these polyfunctionality scores. We see, we can go on and on. So we see all these these are all kind of flow cytometry measures, looking at different cytokines and whatnot. And then, we go further to the right. Eventually, in theory, we would get to kind of the BAMA data, which is somewhere further. Let's see, column 51. Does that work? There we go. Actually, no, it doesn't seem to work. All right. Maybe, there's only 50 columns in this. Apologies. All right. So, we get column name. So this is all just the immune response. Any questions so far?
So I just want to tell, I'm putting this in the chat, but also for the people in the room, I've uploaded the data under data science/data. So those files are there. And I've uploaded the notebook that Richard is showing under data science/RV144. In order to run, you'll need to change the path names so that you're targeting the data directory.
Yes, that's a great
I'll
point.
leave that as an exercise to the user, and if you run into problems, ask me questions.
Thank goodness. Okay, so we have now our demographics data and our biomarker data, and now we want to join everything together. So we take the data IR. I'm going to do left join. And then I'm going to basically then take the column names. So I think this, and then this is just me ordering it in a certain way. And so it says, all right, joining by the publication ID, pub ID. And if we look at that, we get, we get the publication ID, study, age, sex, race, and then all of the functionality scores and immune response stuff to the right. All right. Yes, each row is a single person at a single time point. So this is someone who was 21 to 25, a male who received the vaccine in the HVTN 097 study. But that's a great point is, when you're kind of working with this data, you may want to make sure, right, that there's no duplicate IDs, right? Like if it's a longitudinal study, then yeah, you want to make sure that, maybe there's more rows. Everybody has the amount of rows, but that's a data check that you maybe sometimes want to do. Let's go ahead and do that. Just make sure that everybody only has one ID, one observation, right? So in visual mode, it's Control Alt I to basically show, to get a new R section going. But what I'm going to do is data IR demo merge, and then I'm going to do Control-Shift-M, which is the pipe shortcut that I like. That should be in most Windows R. And then I'm going to do count pub ID. All right, so this is just going to be, all right, here's how many times. So that's not great. But then what I'm going to now do is count in, and I'm going to say name and in. Let's see what that does. All right. So basically everybody's only in there once. So that's good, right? Each of the publication IDs is only in there once. Yeah, so this is basically a faster way to do. Instead, you could do count. You could basically do group by. Sorry, the Band-Aid on one of my fingers. Summarize n equals n. So this is a quicker way to kind of do this, and then basically all right. They're only there 561. Yeah, in an ideal collaboration process, you'd be kind of meeting with and talking with the investigators prior to ever seeing this data. You'd be kind of meeting and talking with people to be like, okay, what is the research question? What is the data you're giving me? And then as you started to go through and merge it, right, you'd go and ask questions back and forth to make sure you're understanding everything. Okay, so what this is doing right here is basically take this data set, we group by publication ID, we summarize. So this is going to reduce everybody to one row, which in this case it is. N, which is basically a function to count how many rows publication ID has. I'm then going to pull it out into a vector, pull that column in, and then I'm going to table it. And that then tells me, all right, everybody, there's 561 people in this, basically, that only have one observation. So if we did something like this, bind rows, everybody would be in there twice, because this is bind rows is basically taking two data frames and like stacking them on top of each other, or tibbles, I guess. But anyway, this is kind of a check you maybe want to do, yeah, when working with some of the data. Any questions? No? All right. So next let's filter just to the RV144 people. And we're going to filter to where per protocol equals 1. So now we've reduced our data set. Basically have data IR. So we're now down to 225 people. Compared to when we had 561 previously, right? Okay. So the biomarkers that they've given us are not all going to be measured in the RV144 data set, just due to differences in the clade and whatnot. So basically, we can kind of drop these biomarkers that are completely missing in RV144. So what do I mean by like all missing? So let's find one. So what this statement is doing is is there missing data in this data IR demo RV144? Okay. So what this is going to do is I'll put this and I'll just get the head of this. So this is like, all right, this isn't missing for this person. It isn't missing for this person. Let me expand it a little bit. And expand it a little bit more. Okay. I want to get to the BMI column. Okay, there we go. All right. So we see, all right, this person isn't missing information on their sex, they aren't missing information on their treatment, they aren't missing information on the protocol, the infection, the race, but they are missing information on the BMI, right? Which we know because the Thai cohort didn't have information on the BMI. And then we have, okay, they're missing information on GP120, CD4, GP120, CD154 positive cytokines. And they're missing information on this functionality score. All right. So this is the NA is just basically taking our giant data frame and just each cell replacing it with a true or false for whether or not it's missing. Okay. So this next part, called means, is basically, so actually, let's do this part first. And now we say, all right, is it equal to 1? So is it actually missing? I don't think we actually need this part, to be honest. Oh, no, sorry. All right, call means. I got my order messed up. All right, so now this is going to take each row and calculate the mean of true and falses. So the way R does this is it treats true as a 1 and false as 0. So when we take the mean of that, when every value is missing, right, we expect to get a mean missing value of 1. Right. So, okay, this is a lot of stuff being printed out. So you can kind of see the numbers scroll by 0, 0, 0, 1, 1. So that's going to be something we're going to drop. So like publication ID. All right, nobody's missing publication ID. No one's missing study. No one's missing age. No one's missing sex. Everybody's missing BMI. We know that. Everybody's missing this measure, and so on and so on. And it may be the case that there's a matched variable, but we're not going to necessarily get into that for the point of this exercise. So we don't, at least for the point of this, we don't want to necessarily continue holding on to these variables, right? Because they're completely missing for this cohort. And so we're going to drop them. So for this, we're now going to do which of this giant vector is equal to 1. And that's going to tell us the columns basically that we're going to drop. And so this all dot missing, I made a mistake here, right? This should be all underscore missing according. But so this is going to say, all right, all underscore missing. All right, and now this is just outputting, all right, these are the columns that we're going to drop. And then to do that, we say, all right, data, IR demo underscore RB144, select and drop. So this negative in front of it means to drop the column. Drop any of these, just get rid of them. And that's going to leave us with basically a data set where hopefully none of these measures are actually missing for the variables. There will be some missing. So you can see here we're missing some functionality score, but it's present for some individuals. And so, typically this would be something where we would go and ask, right, hey, why is this missing for, these individuals, but not other people? And so on. Okay. Any questions? Okay. So the stuff here or can output here. So this is basically, this was maybe, we were maybe going to use this data set. And we were talking about like, well, how into the weeds to the data cleaning do we want to get? So, which is kind of why, you know, we have these kind of notes. Yeah, so we haven't removed the people that have all calls. So we've removed the variables that are completely missing for the people. So nobody, each row is a person and each column is a variable. And so we're dropping all the columns that are missing for everybody in RV 144. Okay. And so within the paper, they ran some of the BAMA data at various dilutions, but they only basically report 40 or 50 dilutions. And so we'd want to basically drop those instances. So I'm going to use the minus again. So if we look at the column names of this data frame we have, you can see basically we have, so these are all the BAMA variables here at the end, but you can see they have this 40 serum, 50 serum, 100 serum, 100 serum, 200 serum, 200 serum, and then which are basically the kind of dilution that they were potentially being run at, if I recall correctly. And so what we're going to want to do is drop those, at least for the purpose of this exercise. And so the way I did that is basically there's a contains argument where basically it will read each of the column names of your data frame. And it says like, all right, if I see this pattern in that column, I'm going to keep it. Or if you put a minus in front of it, I'm going to drop it. So what this will do is basically drop anywhere that you see the 100 serum or 200 serum. Okay. So this will be dropped. 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 So on. Okay. So we do that. Can anyone see a problem? This isn't super informative. The underscore part 2. I think in practice, maybe, you know, I should have given it a better name, but for this, you know, sometimes you just code something and you're just like, hey, this is good enough. All right, so we look at the column names and we don't see any of those 100 or 200 serums anymore. So basically we drop them. We say like, hey, so if we wanted, we could go even a step further and we could say, JK, I don't know why I'm calling JK. You just drop any of the BAMA, right? So if we just said serum, they drop any of these columns that contain the phrase serum. We've now completely dropped any BAMA variable. And we only have these flow cytometry measures. Okay. Any questions so far? Does this make sense? Okay, yeah, great. That's a great question about the flow data. My guess is that they've already been, that they're basically in proportion, so they're relative to some parent, is my guess. Actually, let's just look at it really quick. So, but for the sake of this exercise, the data that the group uploaded, my guess is that it's basically, you know, they've had some pipeline that went from the raw flow cytometry data down into the so apologize for people in the room. So Huang asked on chat, basically the flow data, are these exported as CSV untransformed? So you're just saying basically the raw output of the like parent gates, comma separated, right? So what they
Excuse me, are you saying population is listed under like the different flow data outputs? Like percent
in terms
parent?
of in terms of the CD8 or
Like interferon gamma positive CD4 is given a certain peptide stimulation.
yeah.
So some of the numbers are negative, so I don't know if that works in population.
Okay, so maybe it's been transformed. So maybe it has been like logit transformed in some way. Potentially. Let's see. Forgotten the all right, insert code block R. All right. Actually, sorry, let's remove this. All right, let's just grab one. So which was one that you saw that was negative?
So in the column titled CD4 positive 92TH023, I mean, I could, go on. But one of the columns,
Okay,
if you're on positive, has some negative values.
let's look at that one. This equals, we'll use treatment. Y equals. So there's some missing data. All right, so yeah, it looks like there is some negative data. So let's see. Summary. Work. Yeah, that's interesting. So there is some minimum, there is some data less than 0. Yeah, I don't actually know the answer for why that is the case in this. Oh, thank you. Yes. So Kwong posted in the chat that it may be due to the compensation. So maybe there's some negative flow values there. But typically, yeah, you'd think that they'd be kind of 0 as the base. But that is something, you may want to look at, right? So is trying to find making sure that the data makes sense, and then maybe reaching out to the whoever, or I guess in this case, you all usually sometimes create the data, is trying to figure out what's going on and why that is occurring. So a way you could do that, is that it? There we go. All right. Is basically, I think this will work. If we summarize across where is dot numeric, this work. Fingers crossed. Okay. So okay. So one of the kind of annoying things about tidyverse is, I find it annoying. I don't know if Janice finds it annoying, but they're constantly changing their nomenclature, like the language that they use. So one of the things that they've started is this across statement where it's basically like across these columns do blank. So what this is saying is, all right, across certain columns, I want you to do something.
Yes, I do find it in.
Yes, thank you. Yes. And so basically across where, so this is basically saying, all right, where this condition exists. So where the data is numeric, I want you to do this function. And so the function is basically, so you specify it's now slash x, and then you do min x, and then I'm going to say na.remove true because I don't want to deal with the missing data. And so, yeah, it is annoying. Maybe it's just, you're always got to be learning. So maybe it's good in that sense. You don't want to be too set in your ways, but I find it annoying. And so what this is going to tell us then is for each assay or each of these variables that is numeric, what is the minimum score that we observe? So a lot of negative, for some of these flow kit variables, or not flow kit per se, but you can see that. And I'm going to output it this way. So it just is a long. Okay. No, this is worse. All right. Okay. All right, here we go. So what I did here, summarize, I then transposed it so transpose is taking a matrix and pivoting it. And so because the way it had it originally was very wide, where it was like one row with the minimum and then a column for each. And then, so I'm transposing it, outputting as data frame and viewing. So what we have here is basically each of the variables. So we have the CD4 positive, CD154, we have the minimum value observed. And so you could kind of go through and be like, oh, there's a lot of minimum values here. And then eventually, once we get to the BAMA data, it's no longer the case. And so seeing this many values exactly the same also would suggest some sort of lower limit of detection for this data. Yeah. Okay. All right. And yep. Was that a question or is that just like a chair noise in the room? Okay. Okay. Yes. Thank you, Kwong. So Kwong posted in the chat about basically negative fluorescence that can be observed once they're corrected. So that may be a useful thing to. Maybe I'll post this in the chat, and then we'll update the this R markdown file with this information. So, right, this here. Okay. All right. So let's for the sake of this exercise, let's kind of put those values that are negative. Let's just set them to 0 for now. Okay, so in visual, Janice, have you gone over visual mode or have you just been doing source mode? Okay, so visual mode is basically what you see is kind of what you get editor, which can be very nice if you're kind of coding and you want to see maybe what things will look like. So if you do pound, that'll do basically one header and we can go, all right, set negative value to 0. And then within the visual mode, everything kind of works. Have you all gone over visual mode? No, okay. So we can be like, all right.
I've been talking with my mic off. Yeah, we haven't gone over that. I actually didn't know it existed. So I missed this coming in. I like it though, because one of my biggest complaints is that about our studio on Markdown is that they don't render the Markdown.
Yeah.
So, yeah, this is nice. Thanks.
Yeah. Okay, so we are going to set negative values to 0. And then if we want, we can like highlight text, and if we press like Control I, it'll italicize it. If you do Control U, it'll underline it, and so on. So it's kind of a nice way to kind of, if you're writing something in R and you kind of want to see what it may look like, it's a good way to do that. The spell checker is still terrible though. But anyway, that's a different issue. So this is kind of a nice tool, basically. And so let's do Control Alt I, and let's set these negative values to 0. Okay. So we're going to take this, and we're going to call it part 3, even though I'll do no negativity, only good vibes. All right. So we're going to try the same trick. We're going to mutate across where it's numeric, and we're going to set things that are below negative to below 0, below negative to 0. Okay. So there's a couple ways to do this. So the old kind of standard within R is this if-else statement, which intuitively makes sense, where it's like, if X is less than 0, if that's true, set it to 0. Otherwise, set it to X. Okay. And there's an error somewhere here in the code. Let's see, what's the error? Unopened bracket. I don't think this unexpected. Oh, sorry. Okay. So basic, and then now if we kind of do the same check, everything should be, the minimum should be 0 for everything. Yeah, 0, 0, 0, 0, 0, 0. Except for these, right? Because they had a higher value. Okay.
I have a question.
Yeah.
So the backslash and X in parentheses.
Yeah.
Could you go over what that does?
Yeah, so that's one of those new things that Tidyverse does. So it's basically is saying like it. So Janice talked about like creating a function, right? I think earlier in these workshops. So it's a way to kind of, it's basically creating a function. So where it's going to go, all right, /_x is then like, okay, Tidyverse somehow knows that, oh, this is now creating a function that we're going to do on each of the columns.
Oh, so basically what it is then, it's just like it's a stand-in for the command function, right? So instead of saying function of X to define a generic function, you're gonna do it with just /x instead. So it's like yeah, that's cool. I didn't actually know that existed.
Yeah, so you can not do it, but then I think it just is like, let me see. Let me try to do it now without it. How does it go? Let's say I do this. Does this work? Okay, that works, but it doesn't tell me. It doesn't give me an error. So the way I learned about it, so Kwong is asking how I learned about it. And basically the way I was doing it, they'd output a warning. Not a warning, just like a message, a tut-tut message that was basically, hey, we don't do that anymore. Can you all please, you may want to do it this way. We're going to show this warning once every 8 hours.
Good night.
And so I basically then like, all right, let me read up on what this is. And the other thing is, so there used to be functions that were like mutate if. So one of the things you could do is instead of this mutate across, you go mutate if is dot numeric, and then basically function x, if else x less than 0, 0, otherwise x. Does that work? Okay, that works. So that runs. But then if you go to the help page for mutate if, you see basically this life cycle. So tidyverse has this life cycle thing where it says superseded, where it's basically like these have been superseded by these pick across and whatnot. Use these now instead. And then you kind of have to go read up on how to use those and follow along on their examples. I actually don't know what pick is. I have no idea what pick does. Okay. But yeah, so that's kind of how you learn it. And then you maybe go through this vignette that they talk about and you kind of read through. But yeah, occasionally you'll see this where it'll say, oh, this is superseded. We're done with this. We're implementing new usage. Yeah. Okay. Okay, so we were talking about this if else statement. So another way you can do this is case when. So case when is basically take two. It works when there's more than one condition, right? So if else is really nice because it's two conditions, right? It's either this or that, but that's not always going to be the case. So there's a function called case underscore when, which kind of allows for more options. So we can do like case when, and then you have to specify each of the cases that are potentially going to occur. So it'd be like case when x is less than 0, and then instead you go squiggly 0. He's a and then you could basically have other conditions. So let's play around for a bit and say, all right, if x is in A, I want you to set it to 100,000, right? Or not 100. Is that 1v5 or is that 1e4? 1e4. 5. And let's just say default is just set it to x. Okay. So this is a way to basically have multiple conditions. Oh, thanks. So Janice has put something in the chat about life cycles of RStudio. So I'm guessing maybe that's just how they try to keep fresh, so people keep paying them. I don't know. So I don't have a great answer for so someone's asking in the chat what the .default does. And I actually don't have a great answer for what that's doing. That's one of those things where I've just kind of been like, well, this is how I do this, so this is what I do. But I don't have a great answer for that. Yeah, sorry. Okay. So let's now look at this data, and let's look at, let's instead of the min, let's look at the max to see if this actually happened. So we have no negativity, summarize across where is dot numeric /x, and we're going to take the max. And we probably don't need this anymore, right? Because we've set all the NAs to 100,000. If we view that, you'd see, oh, the maximum is 100,000. Yeah, sorry, I keep on counting the zeros in the back of my head. So yeah, oh, so this must be a variable that didn't have any missing data. But yeah, so the case when is really useful in those conditions, in those cases where you basically have a lot of different scenarios that can arise with your data, and you want to, kind of have multiple, like, all right, if less than this, set to that, if more than this, set to that, or if in between this, set to that. So it's kind of a nice function for that. Maybe one example would be like BMI. If you had BMI and you wanted to use like the classic CDC underweight, overweight, obese or whatever definitions that are probably outdated by this point. But yeah, any questions on that? Nope. Okay. All right. So next, let's just visualize some. So have you all done a break yet? Has there been a break?
No, there hasn't been a break, Richard.
Should we take a break? Let's take a break and come back at 3. Go through the last bit here. Okay. Thanks, everybody.
I started it.
All right. So give it a couple more minutes for people to filter back into the room. Okay, so Janice put a good comment in the chat about the dot. I was asking about the dot function, the dot default, and I'm just going to read her note verbatim that basically is to distinguish arguments that are to the function versus built-in functions in R. So my guess is that there is a function called maybe default or something within or that maybe they want to try not to mess with, potentially.
So I think default is actually gone now. But the default Dutch strings factors is also going away. But yeah, that's essentially the reason for it. That if there is a function named that and built in, then you can run into problems.
Yeah.
But T is a better example, I think, the transpose.
Okay. All right, so now let's go into so this is just going to be purely visualization, and let's just look at some variables that are really highly variable. That so that we can get some nice plots basically. So let's take the no negativity file. And so what we're going to do here is we're going to pivot the columns longer. And so this is going to be basically to get a actually, wait, we don't actually need to do this. Sorry, it's been a while since I've looked at this code. Okay, yeah, we don't need that part. All right. No negativity. So we're going to pivot longer, and the columns that we're going to pivot longer are any of the biomarker columns. Yeah. So pivot is still, so someone's asking about pivot longer. This is kind of a dplyr. I think it's dplyr. It's a function to basically take certain columns and make stack them kind of on top of each other. So let's look at this real quick. Sorry, everybody, I have to remind myself okay. So this data RV144 demo, right, has all this information about the variables. So this was kind of the information about, what antigen is it potentially looking at, what gene, what clade, and so on and so on. And this makes me remind that I forgot to do something. So let me see. So one of the things I like to use the outline, this little function button over here, and you can kind of jump to the section that you want to go to. And I forgot to set the first column of this to biomarker. So now basically, if we look at the head of this, it now says biomarker. And that second M should probably not be capitalized, but these should. So yeah, the outline that can be very useful to kind of jump around, especially as you get longer and longer code. And so find highly variable values. So what this is going to do is any of the columns that are particularly that are in this data RV144 demo biomarker column is going to take those and it's going to pivot them longer. So we'll do it bit by bit, and then we'll kind of do the whole thing in one run. So we take any of these. So this is one of those things where I think if you don't specify it, it maybe gives you an error. And it's going to specify, it's going to put the names to the column biomarker, and it's going to put the values to biomarker value. So we look at this. We'll use the view function. View data long. And so basically we've taken a wide variable, a very wide data frame, and we're going to make it long. So now you can see each row is not a person. Each row is a person and a specific biomarker. So someone in the chat asking, why do we need to do pivot longer before plotting? So one of the reasons, so we're going to be doing this plotting, but one of the things I want to do is kind of summarize to get, find that are more highly variable that we can plot. So basically, this is kind of my way of summarizing across everything. Summarizing across is now a much more efficient way that I need to work into my own personal kind of workflow, because I still kind of do this pivot and then summarize kind of pipeline, which is maybe no longer as efficient. One of the other reasons you may want to do this is there's a facet wrap option where basically you'll have multiple panels, each being a different biomarker. And so we could potentially, if you pivot the data long and you specified a certain biomarkers, you could then maybe have data in a look at multiple biomarkers at the same time in one plot. Okay. Yeah. Yes. And so, all right, so we have the data long. Now I'm going to join with this data RB144 demo. Okay. So now we have the same, well, hold on. It's going to take a little while to view it. We have biomarker value, and then now we have all this extra information, right? ICS, envelope it's looking at, cytokine, genes, the clade, and then this vaccine match information. Oh, it's ICS, so on. And let's just drop the functionality scores. There was a bunch of functionality scores here. So you see polyfunctional. And so that's in factor 3. And we're gonna drop those. So what this does, so we're using the filter statement, and we're going to filter by detecting in factor 3. So factor 3 is a character. And it said, all right, in this character, if you detect score, we're going to, we don't want that. So this says negate equals true. Can anyone would guess if we put negate equals false? Okay, no, all right. Okay, so
Actually, sorry, can you actually go over again what you're doing there with the score from factor 3?
yeah, of course. So let's look at it now that I've run it. Okay. So we basically we're looking at this one column, and we're saying if we see in that column in any of those strings, right? So let's look at this again real quick. Oop. Okay. So it's going to look at this, right? Not the, sorry. It's going to look at this, and it's going to look at each of those strings, and it's going to be like, hey, do I see the set of letters score in there? SC, just in that case. So if the score was under, if it was, this S wasn't capitalized, it would do something different. And it's basically going to look at each of these, and it says, hey, do I detect it? Do I detect score? So for this one, it's going to be false, right? For this one, it's going to be true, false, 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 true, false, false, so on and so on and so on. And then what the negate is saying like, we want them not to have score in it, right? So we're negating that statement. So now it's going to be true, false, true, 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 false. And then we're basically going to filter, and we're going to say we only want where that is true, which is basically going to drop the columns where score is detected in factor 3. Does that make sense? That makes sense? Thumbs up? Yeah, cool. Thank you. So if we put negate equals false, I'll just show this real quick, which is the default. You can see we only have the functionality score variables. So this is just kind of a way, and I didn't have to pick factor 3, right? We could have also just gone right off the biomarker name, the column name, right? Because it has score in it. But yeah, this was just another way to do that. So that's what it's doing. So this is from the Stringer tidyverse package, which has a lot of functions for basically dealing with character strings. All right. So data long. And now we're going to try to find variables that are very variable. And we're only going to look at Bama. So I'm going to take this data. I'm going to filter to where the assay type is Bama. So this is each row. All right, Bama, 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 Bama. And now I'm going to group by biomarker and gene. And then I'm going to basically calculate, not the variance, but I'm going to calculate this MAD, which stands for median absolute deviation. And so that's basically another measure. So variability is kind of getting at, the spread of the data, how much it's spreading out. And MAD is another measure of that is less sensitive to, say, like large outliers and the like. And so we're basically just calculating the variance for each of the biomarkers over each of the genes. So we summarize this. We'll do it piecemeal. So this is basically, okay, biomarker IgG measurement against GP140C, variability of 0.0936, 0.112, and so on and so on. And so what I'm then going to do is I'm going to group by gene, and then I'm going to arrange the variance in kind of decreasing order. So now, all right, we have V1, V2 is looking at, and we have the variability, 2.56, so on and so on. So we've arranged it now. So for each gene, we have the biomarker with the highest variability at the top. And then we just slice one. And what this will do is basically just grab the most variable one. And then we can pull that biomarker to be like, all right, these are the ones that we're actually going to look at. You don't have this part, you actually don't need to do, but we'll do it for this. So this right here, so this is one of the things you're always learning new tricks, right? With R and tidyverse is there's actually a slice max function where basically you say, all right, within these gene variables, just give me the one with the highest value. So just give me basically the row where it has the highest variability. And if we do that, we get kind of the same ones. So that's a way that you could kind of reduce, if you wanted to cut lines of code and whatnot. Any questions on that?
Does slice just take the top or the first row?
Yeah, it takes, yeah, thank you. So that's what this will do, yeah. So you can specify basically different indices. So we could, if you put 2, it would grab the second, right? If you had it arranged from smallest to largest, you would slice 1 would give you the minimum, right? Or if you did slice in, it would give you the one at the bottom, which in this case would be the max. And then there's like a whole bunch of different slice kind of functions. There's like slice head. So this will grab the top 5, let's say, or the tail. You can slice a sample, right? If you want to randomly select rows within a group. The min and the max, which will slice the minimum values. So if we wanted the 2 most variable for each of these genes, you can do arrange, negative, and we would just go either 1 through 2. Should grab the 2 most variable, or I guess we could also do slice head and go n equals 2. And that would grab the 2 most. So basically slice is, I guess, at least to my understanding, is kind of tidy versus answered to, as opposed to doing data long, grabbing 1 through 2 or something like that, right? And subsetting. It's kind of the wrapper, getting around that so you can have it within your pipe. Okay. So I'm going to pull these biomarkers that are highly variable, the names of them, and then I'm going to filter. I'm going to take my data long and I'm going to filter to where the biomarker is in this vector. And then I'm going to plot them. So what this is doing is basically we're taking the biomarkers and then we're doing ggplot. And we're saying X equals treatment, Y equals biomarker value. And then we're saying geom, we're doing a box plot and then wrap it by the treatment. Sorry, by the biomarker. And so you see it says, all right, we removed 1 row with non, so let's get rid of that. So let's filter to non-missing. Oh, excuse you, that was somebody. Okay. So just to get rid of that warning. Okay, so that gets rid of that warning. We see the difference like placebo, vaccine, and so on for each. So this doesn't look, this looks really squished though. So if we wanted to make it not as squished, there's options within these things to go say like fig height or fig width 8. So I'm going to say, I think it's 8 inches or 8, not 8 inches, but something along those lines. And so this will kind of make it look a little bigger. So now we can see kind of each of them. So we see IgG, GP140, GP40, 50 serum, IgG3, and then, IgG3. And so you can see that each of the different ones by faceted out by biomarker and for each against treatment. And so what we're seeing here is that for some of these, we're basically getting the placebo is having no response, right? Because they've never, which kind of makes sense, right? If they have never been exposed to HIV and they've also they didn't get the vaccine, right? They shouldn't necessarily have antibodies that would react to them. Hopefully that's biologically sound. And so, this may look a little gross, so we may want to, let's put the strip position on the right. So we can see it like that. It's a little bit better. maybe not as readable, but then there's other options to maybe make the text kind of smaller so that maybe all fits on one line. Yeah, so when the cramping, there are options. So basically, how do we deal with kind of how cramped it looks? So you either go in and you kind of play around with like there's options for text size to make the strip size smaller, which will help in kind of making this not as it's really only bad for this one and this one, right? But so that would be one way that you could potentially do it. And honestly, I don't know it off the top of my head. It'd be something where I would just kind of go on to kind of just search and be like, how to decrease size of strip text in ggplot. And then typically there's a Stack Overflow page pretty quickly, because you're not going to be the only one who's dealt with this problem. The other options is you give it a nicer name, right? So we're using this biomarker, but maybe there's a nicer name you could actually use. You could increase. So right now we have 3 across, right? So, but there's 8. So maybe it makes more sense to have 4 rows and 2 columns. So what we could do there is you can specify it. You can say number of rows 4, number of columns 2. You don't have to specify the number of columns. It'll figure it out. And so this will kind of make it a little bit not as cramped, right? So you can see now you can kind of read everything without it being really squished. And then if we wanted to, we could also add it to basically be basically looking at, say, having it on let's make that a Y, on the log 10 scale. So this is like scale _ Y _ log 10. So now everything's on the log 10 scale on the Y axis. And if we wanted nicer labels, right, if you were actually going to submit this to a journal, right, you wouldn't want it to be TRT or biomarker _ value. You'd want to have something else. So you'd go like labs, X equals treatment, Y equals BAMA value. That could probably still be better, but for this purpose, it's probably fine. Okay. And you can also specify, so if you wanted them in a certain order, you'd have to specify the factor. You'd have to create them, make them basically a factor, and then have them in that order. So if we wanted to, say, have the facets out by the most variability, the way we would do that is we say mutate biomarker equals factor FCT reorder. And so what this is going to do, was there a question? No, okay. Is basically reorder and make this a factor based on some second variable. So we're going to reorder biomarker based on biomarker value. And we're going to make the function that it's based on the MAD, right? So here, the default is the median. And so now it should be ordered. So we have GP41 here, right? It now should be ordered by the ones with the most kind of variability. So likely these 2 and these 2 will likely be at the top, is my guess. Okay. All right, other way around. So So now we have basically, we've ordered everything by the variability in the data. Oh, wait, did it actually change at all? But yeah, so there's multiple different ways you can kind of play with facets, and it's really useful for paneling things out if you want to have multiple multiple variables within a plot. Any questions on that? I feel like this is one of the things I use the most in ggplot. Okay. So it's not maybe super interesting. Well, it is, but let's get some of the variables that are maybe variable within vaccinated people. Okay, so we're going to take that data, that long data we made, and we're going to filter to where the treatment is vaccine. And we're going to do the same thing and grab the top. This is okay, it runs. So now we're going to have a different set of potential biomarkers. And actually, I'll grab the top two again, just to have the same. And let's figure height 8. And then I'm just gonna copy some of this code. Actually, let's just run this for now and see what it looks like. All right, so we see that warning about missingness. And so these are, so basically looking at these and saying, all right, we know that these are highly variable, but what are they maybe variable with regards to? Are they with regards to sex? So we don't necessarily see anything there. So we could also look at it by age. So if we wanted to look at it by age, okay. Well, yeah, I'm not really seeing anything here. So we have age, so we have less than 20, 21, 25, and then 26 and up. But yeah, at least within the vaccinated, there doesn't seem to be that much jumping out to me in some of the variables. Maybe there's a little bit of increasing here. Okay. Well, let's now let's do a simple analysis where basically let's find variables that are maybe associated with sex or age in the vaccinated group. Okay. So if you were actually doing this, right, you'd want to think about it and, work on and maybe talk with a statistician, think about the distribution of the data, what variates you want to adjust for, and so on and so on and so on. But for this, we're just this is a toy example. At this point, it's a toy example. It is a real study with important implications. But we're kind of just treating it as something to test. So we have that data long. We're going to filter to the vaccine group. I'm going to drop where it's not missing for the biomarker value. Okay. And then I'm going to group by biomarker and gene. And then I'm going to calculate the p-value for age and then for sex. So what LM is? LM is a linear model where it's going to basically model the Y is going to be on the left hand of the formula, the tilde, and then your explanatory variables on the right. So I'll walk through this really quick for an example. We'll just use the whole data as an example. Even though that's maybe, not entirely correct. Because of basically, there's going to be correlation between observations and, and so on. But at least for now, let's do that. And so the reason why, at least for this, I'm log10 transforming the data for the linear regression is to try to get it to be more normal behaving, to look more like a bell curve. Just because that makes some of the assumptions of a linear regression kind of more feasible to be addressed. So if we wanted to do, say, some kind of non-parametric method, we could do something called Kruskal-Wallis, which is basically a testing for whether or not the medians are the same between groups by looking at the rank of the data. So it calculates the rank of the ranks of the data, then calculates the mean rank in each of the groups and compares those. But for this, we used LM. So let's do a dummy example real quick. So log10 biomarker value, age, data equals data. All right, so if this works, oh, there's 0 values in the biomarker. Does data long have BAMA data in it? Okay, there's BAMA data in it, that's fine. Okay. All right, so we'll just add 1 for now. All right, so this wouldn't be an actual regression you'd want to do, right? Because your linear regression, at least the one that we're doing here, is assuming that each of the observations is independent from each other. Which isn't the case here because we have data from the same person like multiple times, right? We're basically just stacking all their data on top of each other, and we're not even looking at whether or not the differentiating by flow, or if it's score, or if it's BAMA. We're just kind of jumping it together just for the sake of this example. Actually, let me just grab one of these. But let's just that makes it easier. Let's just all right, let's just filter to where biomarker equals. Okay. All right. So I've now changed my mind, and now we're looking at basically we're analyzing this BAMA value, IgG3, GP70. D1 40 serum. All right. So the way LM works is you have the Y, you have your X, and then if it's not within a dplyr or a summarized statement, you have this data telling it what data frame to look at for these variables that you're specifying in the formula up here. So this is actually an object class in R called a formula. And so what this is going to do is run this regression and estimate basically coefficients corresponding to the intercept, age of 21, 25 versus people under 20, and people age 26 or older versus people under 20. So this is called reference coding. So this is basically looking at the mean log10 biomarker value. We actually don't need to add for this one for the BAMA because the BAMA didn't have any. So this is looking at what's the estimated mean difference in the log10 biomarker value between two individuals where the only difference is that one is, say, 20 or younger versus 21 or 25. So we guess that we estimate that on average, it's going to be 0.03 higher. Then age 26 is basically the same interpretation, but now it's age 26 versus age 20 or younger.
Can I ask really fast?
Yeah.
So the way you have it, I mean, the pipe command is inside of some parentheses.
Yeah.
So I guess it resolves everything and then applies the linear model to it.
Yep.
Okay, so where the tilde age is occurring, that is affecting the linear model. I mean, yeah.
Yeah. So this is saying this is the model that I want you to fit.
Right, that applies to the linear model function or whatever, basically. Okay.
Yeah.
So when that gets piped into the filter command, the filter function, it just has that. Okay, yeah. Sorry, I'm just trying to visualize what kind of object the linear model function is applying to here.
Yeah. So if I recall correctly, what it's doing in the background, so it's going to do this first before anything. So it's going to make some internally, it's going to make some data frame, we'll call it data underscore example that it's going to use for this analysis. So, and then what it's going to do is like, all right, this is the data frame we're using. And then it's going to have this formula here. And it's going to pass that to another function that's then going to turn that into like a matrix that then this linear regression is fit on. And then the regression and the estimates are going to come out of.
Generally, the pipe, though, right, like it first resolves the first step and then passes it to the next function. So in this case, it's still doing that. It's just right. Okay.
Yeah.
No, I think it makes sense. Yeah.
Yeah. Yeah. And if you ever are like super curious and really want to dig into the weeds of these functions, so let me see. That's it. Where is it? Sorry, I always forget this part. Janice, do you remember what the code is to get the methods? It's R.
I'm sorry, I'm talking while muted again.
Yeah, it's okay.
Isn't it just methods?
Oh. Oh yeah. All right. Methods. Oh,
You could probably have put in code.
yeah, there we go. Okay. So, and I think if we look at, say, lm.fit, it'll give some information about what it's doing. Oh, actually, so this is one where you didn't have to do this. So this is so if you really want to get into the weeds, so if you just lm, it'd say, all right, this is the function, right? Formula, data, subset, weights, what method it's using, and so on. And then it can kind of, if you want, you can then kind of go down and try to figure out what exactly it's doing in the background. It's not necessarily always going to be pretty, but like if you really want to know sometimes what a function is doing, you can always dig in and try to find it because R is open source. Maybe ANOVA is a better example. Okay, so ANOVA, all right. So if we do ANOVA.lm, it's going to be like, I don't know where that is. I can't tell you. See, it has a little star by it being like, no. So I think it's get anywhere. You go ANOVA.lm, and you can see like what the function is actually doing. And so if you ever are really interested in trying to figure it out, you can find out like what everything's doing on in the background. And a lot of these base R functions. So in the chat, Quang asked why I picked linear regression for this. It was just mostly I'm feeling that people are interested in this and just being like, well, this is kind of a simple data experiment. Let's use a method that maybe people have heard of. I actually, I'm not on the paper that this project, they did a complete, their analysis is very different from this. So, yeah. All right. So yeah, if we do this, right, we get our, oh, didn't run this part first. You get the estimates, right? And if we wanted to say get a p-value, so I'm gonna set this as something real quick, run fit. So I'm gonna save this as an object really quick. So we go run fit, gives us its estimates. But if we want to like to get an estimates of a p-value, so we go summary, run fit, and you basically get these different estimates, standard errors, the t-values. And so this is all more statistics that maybe I think part of the next workshop series gets into more details on. And then information on age and whatnot, and the estimates and the standard errors. The intercept typically isn't super useful, right? The p-value there, it's just telling you, well, the mean's different than 0, you know, for someone at a 20 or under. But this doesn't tell us whether or not age is significant overall, which is of interest. So there we would say do a ANOVA. So we do ANOVA, run fit. This is basically testing for there being any difference in age in this biomarker by age. And we see it's not significant. And so then really quickly, I'll run this and then we can have maybe some questions. So I'm going to take this data set, right? I'm going to filter to where it's vaccine. I'm going to drop the non-missing. I'm going to group, and then I'm going to run these regressions. I'm going to filter to where I'll do the +1, which isn't great practice, but for the sake of this exercise, let's go ahead and do it. And then this right here, 1 and 5, will basically grab this p-value. So if we do ANOVA 5, you see 0.7237. So if we run this, we now have a p-value for each biomarker, for each variable, for age and then for sex, for each of all of the biomarkers that we were interested in. And then if we want to say, look at ones that are maybe, are there any that are interesting? So we could look at all p-values and we could say arrange by value of sex. Say, all right, there's a couple, let's grab those, all right? That's what this is doing. And then we can do that plot again. So these were some variables that look to be, let me do this again real quick. One, scale 1. All right. And so these are ones that were kind of marginally significant, where it looks like males maybe have a lower value than females for these two biomarkers. And this would be another thing where we would play with the figure height to kind of get it to not look squished. But yeah, again, this may be just due to outliers, so you could potentially run it looking at, adding, running it via like a Kruskal-Wallis, which looks at the rank and is a lot less, doesn't have as big of a problem with these outliers or weird spread. So I think maybe we should just call it for now. We got like 15 minutes left, so I'm happy to answer any questions at this point. I want to apologize again for not realizing that essentially presenting today. I'm sorry about that.
Yeah, no, I'm going to take responsibility for that, Richard. I really should have reminded you.
No, it's okay. It's okay.
One other thing, I would like to do the survey. Do you have, can you put the QR code up for the survey?
Yes. Let me get
And
that.
attendance, me too. So people, can you put in the chat? Can you put the QR code in the chat?
I gotta find the survey. Oh, I need to find the link. Everybody, please hold on. Don't leave. Please don't leave. Okay. All right. Copy. See if this works. All right. Going old school. All right, I got Paint open. Can people see this?
Yep.
All right. So I imagine this looks pretty silly in the classroom.
It worked.
It worked. Yeah, that's all that matters, I guess. Yeah, and also don't forget to fill out the sign-in sheet if you haven't. So that's always useful information so that we can know who all is attending. But yeah, thank you all so much.
And I just want to thank everyone. I noticed there was there's more feedback in the survey last week. I really appreciate that. Yeah, so I'd love to have more of the same. Thanks.